Welcome everyone. This is the question number 8 of the CBSE sample paper 2025. The distance of closest approach of an alpha particle is d when it moves with a speed v towards a nucleus. Another alpha particle is projected with higher energy such that a new distance of closest approach is d by 2. With what speed of projection of the alpha particle in this case? Okay. So let us try to understand what is the concept behind this. Let us understand from the basic. Okay, so if you think that this is the nucleus, okay, and it have the positive charge Ze, or Z is atomic number. Okay, you don't know the atom, does not matter, but it's a positive charge. An alpha particle starts moving towards it from here, let us say, okay, and it have the velocity v and have the kinetic energy half of mv square. Mass is the obvious name is the mass of the here the alpha particle. Alpha particle is positively charged, okay, nucleus is also positively charged. So as the alpha particle in the course of path comes towards the nucleus, it will feel strong repulsion. Okay. So what will happen? Its kinetic energy will decrease. So we can say decrease in Ke of alpha particle. Okay. Not electron, alpha particle. And that should be equal to the potential energy between alpha and nucleus, okay. Let us say when it reaches here at the point P, the complete energy, or we can say the fuel of the alpha particle is used up completely in overcoming this strong force of repulsion. So what will happen? The kinetic energy is decreased and the potential energy between the nucleus and the alpha particle increase. When this complete conversion is done, the alpha particle can reach up to that point, and this is the distance d, which is called the distance of the closest approach. So under these considerations, we can say half of mv square minus of half of 0, half of m 0 square, that is the 0 here. Initially it have the half of mv square, finally it becomes 0. Okay, so decrease in kinetic energy, and at that moment the potential energy is Jd, charge of the nucleus, multiplied by the charge of the alpha particle, let us say q alpha, multiplied by divided by 4 pi epsilon naught small d, that is the distance of closest approach here, that is the d here. So half of mv square, and that is equal to z of e, q of the alpha particle, charge of the alpha particle, 4 pi epsilon naught d. So mass of the alpha particle here, z, that is the atomic number of the nucleus, e is the charge of the proton, 1.6 × 10 minus 19, alpha particles charge, 4 pi epsilon naught, all are constant except v square. So we can say v square equal to constant multiplied by 1 divided by d, or we can say distance of closest approach is inversely proportional to the square of the velocity. So when the distance of closest approach is d, then at that moment we can say the velocity is v according to this first information. When the distance of closest approach is made d by 2, then what is the new velocity? We can say v prime square. So if I just take the ratio of these two equations, d divided by d by 2, so that will become 1 divided by v square, 1 divided by 1 by v prime square. I think you understood that. So from here it will be v prime square divided by v square, and here d by 2 cancels out, it will become 2. So this will be v prime square divided by v square. So 2v square equal to v prime square. So from here v prime, the new velocity with which we have to send it such that it can reach to the distance d by 2, that is root over of 2 into v, root over 2 into the previous velocity, okay, times the previous velocity. So option B here, it is the correct option. Thank you all of you.